Good afternoon, and welcome to OpenStack Now podcast, episode 10. As most of you know, NFV is a big topic in today's OpenStack marketplace. It's the subject of numerous conferences and get-togethers and an explosion of new products, a great deal of capital moving around in support of network functions virtualization, and the redefinition of how service provider telco networks function. We have with us today Martin Taylor, who is the CTO of MetaSwitch, an originary and significant player on the NFV front, and one with a fundamental interest in OpenStack as a platform. Helping me out this week, in the absence of Nick Chase, is Ken Hui of Platform9, who you've met before. Gentlemen, welcome.
Hi.
So Martin, MetaSwitch is a UK-based company. When was it founded?
Actually, we've been in business for about 35 years. So we're not a startup by any means. We've been developing communication software, I guess, since about 1980, which is when the company was founded. Long history of supplying communication software to OEMs, so protocol stacks and control plane software that we've sold to pretty well all of the big names in the networking equipment industry. And about 15 years ago, we broadened out and started building software for telco networks. And for the first 10 or 15 years, that software was packaged in appliances. And I'm talking about soft switches and session border controllers, those kinds of network elements. But essentially, what we were developing was just the software, and we were packaging that software with commercial off-the-shelf hardware as an appliance. But now, of course, in the world of NFV, the software is deployed just as a pure software package running on a generic cloud infrastructure, and that works just fine with us. So essentially, we can take our the software that was designed for an x86 based appliance and deploy it in the cloud. So that's kind of potted history of the company.
So MetaSwitch's technical perspective, then, at least institutionally, has embraced the entirety of the evolution from classic customer premise telco and network equipment to custom, off the shelf or increasingly commodity hardware platforms running installed firmware, to the present and go forward vision, which is about commodity hardware running extremely refined software loads.
Yeah, I mean that's a good way of putting it. The industry was dominated by proprietary hardware, when we started, and so what we built was very portable software that could easily be integrated into any particular hardware platform. And of course, that portability and the know-how of making things portable has been a real help to us as we've put stuff on x86 and then increasingly move stuff into the cloud. And by the way, more recently, we've started building cloud-native network functions, which I can talk a little bit more about that. But the idea that you're building software specifically for deployment in the cloud, in virtual machines typically, or maybe even in containers. You come at the design of the software for those types of approaches in a very different way than designing software for a physical appliance.
So that's interesting. So the moment at which MetaSwitch began, inserting a new vision was actually some time back. Was that the transition?
It was, yeah. I mean,
customer premise and relatively more open hardware platforms.
So, well, I mean, we've always believed in open hardware. So, for example, when we launched our session border controller product 5 years ago or so, we built that on a completely standard x86 platform. Now, all of our competitors in that space were and still are running on proprietary hardware. So they were using network processor chips, digital signal processors, content addressable memories, all silicon tools, if you like, for achieving high performance, high throughput, and so on. And we just didn't believe that was the right approach ultimately. So we figured out how to write software that really leveraged the power of x86. I mean, these chips have got a tremendous amount of processing power, and it gets better all the time, and more cores to play with. So we just have a lot of expertise in how to leverage the instruction set, how to use the cache really effectively, and therefore how to get really high performance out of that hardware.
So I hadn't thought about that. So you're innovating in a new way that's actually an upgrade to an old way of innovating. I mean, we began years and years ago, 25, 30 years ago, with just a CPU. And then the digital signal processing revolution came in, and we had all that different power and math coprocessors as well, depending on what kind of processing you were doing. But then Intel began adding, and others, of course, began adding cores, and now the vision is parallel CPU cores and multi-threading in that kind of software. It's bringing it back onto the mothership platform to perform the operations. What kind of compiler products have you fooled around with too? Can you even talk about the stuff that you use? Are you using commercial compilers?
Yeah. There's no secret. There's no secret sauce in the compilers. I mean, the widely available compilers are kept well up to date, and you get to use the new instruction sets as soon as they're available. And I think the important point to make here is that Intel has invested very heavily in enhancing the x86 architecture and instruction set, with a specific focus on the communications industry.
Sorry, go ahead.
Yeah, go on, Kenneth.
I was going to ask, so how do you package the MetaSwitch software? Are you sticking strictly with commodity switches, or are you working with any of the big OEM vendors? Maybe going to the x86 route?
So the software that we provide does all of its work on an x86 processor. Okay, so we're not talking about white box switches with merchant switching silicon. We're talking about relatively compute intensive applications that are a lot of them are operating in the control plane of the voice network. So the main field of expertise we have in virtualized network functions is around the IP multimedia subsystem, handling SIP, session border control, telephony application servers, those kinds of things. So there's a lot of control plane stuff there, which is compute intensive and runs very nicely on x86. And then we also do some media plane stuff. So voice processing, media relay, media encryption, decryption, transcoding, that kind of stuff. Some of that is not ideally suited for x86, transcoding particularly. But these are all workloads that are deployable, in virtual machines on an OpenStack environment, just like any other kind of application.
What kind of services are you looking for from a virtual machine in that case?
Most of the control plane software really is not at all demanding on the underlying infrastructure. It doesn't require anything very special. And actually, the product I talked about designing virtualized network functions in a cloud native kind of a way, which we started doing, by the way, late 2011. So we really got a jump on the rest of the industry, I think, in anticipating the whole cloud native movement for network functions. But what we actually chose to do at that time was to use Amazon Web Services as our development platform. Now, on the basis that this is about as generic a cloud as you can get. If you can build something that performs well and scales well and is highly fault tolerant and runs on AWS, then you've got.
It should run on almost anything.
Exactly. Yeah.
Now, so you're not bound to the CPU to the extent that you require NUMA or CPU pinning or all of that sort of go forward stuff.
It depends. It depends, right? So for the control plane stuff, where we're processing SIP signaling and applying control plane logic, telephony features, all that sort of stuff, the answer is no. Those are IT-like workloads in the way that they use the infrastructure. If you're talking about media processing, where we're handling, and just to give you a sense of the scale here, on a single host, we might be forwarding 50,000 concurrent voice conversations. Each of which is pumping 100 packets per second, 50 packets per second in each direction.
Is that a 4 kilohertz voice conversation?
That is telephony grade, yes.
Telephony
typically
grade, right.
yeah. So you each media stream, you're looking at a packet every 20 milliseconds, and the packets are about 100 120 bytes, that kind of size. So we're pumping 5 million packets per second. We're having to look up flow descriptors, rewrite headers, maybe do some encryption decryption. That's where we need dedicated processing power. We need to pin CPU cores. We definitely need NUMA to make sure that we're getting we're avoiding those inefficiencies of hopping between different memory spaces, and we're leveraging techniques like SRIOV, where there's an adapter that supports it, and we're also working. DPDK plays a big role here. So our applications in that space make heavy use of DPDK and can benefit from DPDK accelerated vSwitches if they're present in the underlying cloud fabric,
which is Intel's data plane.
Data plane development kit.
Okay.
Yeah. So that's the Intel software. It's open source, which they developed to, provide a toolkit for people that needed to kind of really pump packets between the wire and the virtual machine as efficiently as possible.
And I haven't actually looked at it. Is DPDK now represented at a high level in Intel's developer tools, or is it more like a library that you just bind in?
It's been available from Intel for quite a while. I mean, you just Google it, and the tools are all there. There's a dpdk.org open source website and so on. But I mean, the key thing about DPDK is, I mean, in the cloud environment, you need it not just in the application software. So we've put DPDK into our session border controller code so that it will run really fast on bare metal. But then if you want to make it run really fast in a cloud environment, then either you need to connect it to the metal directly using SRIOV, or you need a DPDK accelerated virtual switch fabric, which will again give you that fast software path between the guest application and the wire. So there is quite a bit of specialist know-how in this space, and almost a bit of black art, if you like. But the DPDK technology is out there, and obviously a lot of other people are making use of it.
Ken,
if we could change gears for a minute, maybe you can talk to us a little bit about how you are working with OpenStack. Is MetaSwitch have a plugin? Was it related to some of the things you're doing around Calico? Can you talk a little bit about that?
Okay, sure. Okay, so what I've been talking about so far has been around our virtualized network functions. So think of those as applications that sit on top of OpenStack as a cloud infrastructure. And as far as OpenStack, our engagement with OpenStack there is concerned, I mean, we have been engaging with the OpenStack community through the Telco Working Group in describing specific requirements that we have, things like NUMA that you guys identified as being needed for performance optimization and QoS and good quality. But we've also been engaging the OpenStack community in the fabric layer. And this is a completely separate initiative that's going on within MetaSwitch. This is an open source project that we sponsored and announced about a year ago called Project Calico. And this is coming at the cloud networking fabric really from a very different kind of perspective. And this came out of our observations, when we first started playing with OpenStack as an NFV infrastructure, we observed a number of challenges around the way the networking model operated. This idea of emulating a layer 2 segment by means of an overlay, it's complicated, it's messy, and it isn't necessarily the abstraction that application developers, really need or feel comfortable with. So what we did with Calico was we said, let's simplify the heck out of the whole
layer
approach to networking. Yeah, exactly. So instead of having a vSwitch, we effectively, with Calico, we have a vRouter in each compute node, and we have so every workload, with VM or container, its first routing hop is right there in the compute node. So we layer 3 forward packets between virtual machines and onto the wire. So it's just native IP networking throughout the data center, all very, very simple, all very easy to troubleshoot. And we also have with it a very powerful policy framework so that when you deploy your workload, you can specify exactly what connectivity you need, which other IP addresses you need to talk to on which ports, which groupings of workloads need to talk to which public IP addresses need to be exposed on which ports, and so on. And all of that policy information is then rendered into ACL rules, access control list rules, in each compute node. So what you end up with is something like a kind of distributed firewall throughout the entire fabric that locks down connectivity to exactly what the applications need. So it's kind of purpose designed rather than just let's build an abstraction of a layer 2 network. This is more, what do we actually need when we want to connect workloads together, both from the point of view of connectivity and security, and that's what Calico is all about. Now,
you recently validated a plugin for Calico with Mirantis, didn't you? Calico folks did, anyway.
Yeah, so a number of different strands with OpenStack here. I mean, the first thing was we needed some patches in Nova and in Neutron to for Calico to work, because Nova and Neutron, think it very much in terms of layer 2 abstractions, and this is a layer 3 abstraction. So, as I say, we needed patches in Nova and Neutron, and within the last couple of weeks, we've just managed to get both of those upstreamed. So the Liberty release, will not need any special fork to run Calico. So, we're fully emancipated, if you like, in the networking community in OpenStack. But we've also been working with Mirantis on a Fuel plugin, so that when you use Fuel to deploy OpenStack, Mirantis OpenStack, you can choose Calico as the networking fabric and have Fuel deployed all at the same time. So that's I think it's pretty much nearly there. It's work in progress, but I think we're pretty much there with that.
And just so the audience is clear, what is Calico plugging into Neutron? Is it replacing Neutron?
No, it plugs into Neutron. Yeah. So you program the network, the Calico network, via the Neutron API. But you have to use the Neutron API in a slightly different way, because you're not programming subnets and open Neutron networks. There's a slightly different programming model, so the orchestrator has to take that into account. And of course, the Neutron API doesn't allow us to expose the full richness of our policy model. So you don't get all the benefits of Calico in an OpenStack environment yet. But one of the discussions we're having in the community is maybe there is another layer or maybe some kind of parallel effort to define a networking API that's better suited for the layer 3 centric approach that Calico exposes. And the buzzword that people use a lot here is intent-based networking design. So what you tell the network is what you want the connectivity to be, rather than describe the network in terms of abstract layer 2 segments and that kind of thing. But this is the Neutron discussion is fraught with challenges. There's a lot of politics around Neutron, as you're probably aware. So it's not an easy conversation to have, but there's certainly quite a lot of discussion going on around how to address that.
Yeah. So this is replacing basically a layer 2, like a vSwitch solution.
Correct. Yeah. Exactly. So instead of deploying an open vSwitch, effectively you deploy Calico as the equivalent. So it's giving you doing the same job as open vSwitch, but in a fundamentally different way.
Okay. Yeah, I've heard a lot of good buzz about Calico. A lot of talk about it at various meetups and OpenStack operators meetings. So you guys are doing a good job of getting the word out on it.
Thank you. Yeah.
So getting back to the SBC question, your main product is the Perimeta line.
Correct. Yeah. So Perimeta is the name of the session border controller product. So this is an appliance, software appliance that sits at the edge of a telco voice network, either facing users or interconnecting with other networks. And it has an unbelievably complicated set of roles that it plays in the network. It acts as a security gateway. It can provide interworking between IPv4 and IPv6, interworking between private public IP addresses. It can provide interoperability between different dialects of SIP. It can do transcoding, and I mean a myriad of different functions that are required at the edge of the trusted core voice network, facing the outside world. So we, as I mentioned earlier, we built the software originally for x86. It is somewhat decomposed in the sense that we have, the SIP signaling is handled in one software component. The media processing functions are handled in a different software component. They are independently scalable, and that's one of the things telcos like about Perimeta, particularly in an NFV environment. When you're scaling stuff out, you can instantiate as many instances of the function as you need, and get the amount of capacity that you want. The effort over the last year or two has been to get that Perimeta software running really efficiently on OpenStack with a variety of different kinds of networking approaches. And I've mentioned some of those: SRIOV, accelerated vSwitches, and so on. And then we've been working with OpenStack partners, like Mirantis, and recently, working very closely with Mirantis to get Perimeta onboarded onto their particular distribution of OpenStack, so that it installs cleanly. Performance is kind of qualified and understood, and taking the uncertainty, if you like, out of the picture for customers who are interested in deploying this kind of network function on a Mirantis OpenStack deployment.
The so in effect, your product doesn't care what OpenStack distribution it runs on. I mean, you're agnostic about hosts for the NFV component. Is there something that you think telcos are looking for in particular in the OpenStack that optimizes it somehow for use in this particular use case?
Well, I think the main thing that telcos want is a fairly high degree of vendor independence and avoidance of vendor lock-in. So, they put a strong emphasis on open source, and they like the fact that we are as independent of the OpenStack distribution as possible, so that we don't inadvertently, but by selecting our product, they don't inadvertently then lock themselves into a particular situation that becomes problematic later. So I do think this notion of the independence of infrastructure and virtualized network functions is a very fundamental part of the overall NFV value proposition. So that is the key thing. Now, we do often get asked the question by customers, okay, so what does Perimeta need from the OpenStack infrastructure? What do you guys tell us that we have to have in there? And our response to that is always, well, what does your infrastructure look like? And then we'll give you an idea of how well Perimeta will perform on that. So Perimeta doesn't need anything specific. What it needs is an infrastructure that is capable of pumping packets quickly. If you give us access to SRIV, we can take advantage of that. If you give us access to an accelerated vSwitch, we can take advantage of that. If you're just in the pure open vSwitch environment, well, frankly, the performance isn't going to be very good. So what we say to the customer is, we will work as well as we possibly can given the limitations of the environment, and we'll help you to make those choices in an informed way by giving you performance numbers with this product in different kinds of environments.
So the implication then is that being unlocked is critical, not just because I suppose hypothetically there are covert ways to tie VNF to a preferred infrastructure, but also because, frankly, you're giving telcos the opportunity to shop and engineer a hardware solution under their mid-plane and VNF solution with relative freedom. I mean, they can get their SRIOV from one place or another place. They can buy their host operating systems from or download their host operating systems from a range of places, and thus also with other components of the hardware suite. So they have significant flexibility, presuming they're not trying to deploy on existing infrastructure to optimize the solution under the software components, and then presumably to continue to optimize it as better hardware becomes available and better software becomes available.
Absolutely. I mean, look, let's make no bones about it. I mean, telcos are under enormous pressure to massively reduce their costs. And they look across at the internet world, and they look at examples of what they refer to as over-the-top services like WhatsApp, where with 60 engineers, there was a company able to build a service that's supporting 500 or 600 million users, and at a cost of pennies per subscriber per year. I mean, this is so far removed from the way that telcos have built their networks in the past. They've got to make substantial moves in that direction, and so they are looking for every conceivable way in which they can. Without compromising their core values of, carrier grade and all that sort of stuff. But, they absolutely need to take advantage of every possible technique they can. And frankly, that means treating as much of the network as they can as commodity, so that, they get the advantage of the lowest possible price for, those high volume components that are going to be supporting the services.
This is a profound, not only a technology change, but I would imagine a cultural change. Though I suspect at this point, telcos are being run by a generation of people who understand that this kind of revolution, can and must happen, and are probably promoting it much more actively than the generation that was in charge of telcos in the mid-90s and first being stricken with the idea that, oh my gosh, everything's about to change, everything's about to open up. The computer telephony revolution, for example, which seemed a lot more troubling, when suppliers like Northern Telecom began producing what were effectively, SIP phone systems in a commodity PC, as opposed to the big card-based analog and digital analog phone systems that they had produced for years, and of course doing the same thing at the up in telco grade. That felt like a more painful revolution. Are telcos embracing this more wholeheartedly than they did the last time everything changed for them?
Oh, absolutely. I mean, this is a much more fundamental kind of change that's taking place here. I mean, they are having to get to grips with so many new concepts. The idea that that software is really where it's all at. They might have to embrace a sort of DevOps style culture at the extreme to get the service agility that they're looking for. And as I say, they've got to engineer a huge amount of cost out of the network. And of course, the big challenges. I mean, there are definitely massive cultural changes that they have to wreak, but they also have to there's a big shift in terms of skill set here. Most telcos, most of the people there have tremendous subject matter expertise in protocols and interoperability and how to specify boxes to build complex services. They don't necessarily have the know-how for deploying software on a cloud environment and how to evolve services rapidly. The way that services have been built in the past by telcos is, it's a 3-year process. Describe the service in excruciating detail, then you go out to tender for the boxes that are going to build that, and then you spend a huge amount of time integrating with all your operation support systems and so on, and then you end up with something that's relatively fixed at the end of the day, and it just has great difficulty evolving. And all of that has to change in this new world. And the telcos they're embracing NFV. They absolutely do understand this, and people like telcos like AT&T have written very eloquently about the scale of the change and the breadth of the change, and they really do understand where what the end goal is here. But none of them should underestimate the difficulty and the challenges of getting there. This is hard.
Well, then it's going to be an interesting next, how many years would you say? 5 before the transition is substantially underway, complete?
I think we're going to see things happen more quickly than that. I think we already have production deployments of virtualized network functions, but I would describe them as kind of tactical deployments, little islands of cloud technology running this stuff in a kind of point solution way. But I think we're seeing mid 2016, for the first kind of serious deployments of NFV, where we are talking about a generic platform that's been built to be general purpose with some orchestration software that can kind of automate the lifecycle management of the applications. So we're probably no more than a year away from that kind of reality. Now, the transition as a whole, is going to take 10 or 15 years to kind of permeate the whole network, because there's a lot of assets out there that are still depreciating. But it is getting underway.
Exciting times.
Yeah.
Ken, did you have any more questions? I think that we have to be respectful of Martin's time.
Yeah, no, it sounds like you guys are doing great work. So it sounds like you're really tackling this from two ends. One is obviously your solution, but also what you're doing with the NFV working group to kind of lay out the foundations of what the requirements are for these telcos to kind of make that change. Are you so? How far along is that working group? Have you defined some of like a version 1 of those requirements?
It's an ongoing process, and so there are there's a whole long list of requirements out there in the OpenStack wiki. There are bits and pieces are kind of making their way into the process. But we also have to be. The NFV community has to be respectful of the fact that OpenStack is much bigger than NFV, and there are a lot of other priorities, and the demands that the NFV world is making, are quite. There's a lot of stuff that the NFV world would like to see OpenStack do, and there are limits to what that community is able to process. So I make no bones about it. There is some tension there, without any doubt. But it is moving forward, and we are seeing encouraging signs of progress.
Terrific. Well, thank you very much, Mr. Taylor, for joining us this afternoon, particularly in such an agile fashion. I understand you're planning on coming over the pond to see us on Monday, and I wish you the best of safe travel.
Thank you.
And we'll be looking forward to seeing upcoming news from MetaSwitch about these products.
Great.
Thanks also, Ken, for joining us. I am far less versed in modern network technology, I'm sure, than you are, and having you here on my hypothetical right hand, even though we're probably a couple of miles apart in reality, was extremely reassuring. Thank you, audience, for watching. And next week, we will be back, hopefully with Nick Chase and another fascinating guest with OpenStack Now.